Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And in studio with us we have Addie. Addie, if somebody wanted to get a hold of us at Do the Math, what would they need to do?
For math homework, help call in Bakersfield 6364357, toll free 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
A lot of sixes in there, aren't there? Hey, while we've got you here right at the beginning of the show, why don't you let everybody know where you go to school and what grade you're in?
I'm homeschooled. I am 9 years old, and I am in 4th grade, and I also go to theatrics kids.
Excellent. So how is the 4th grade stuff that you're doing right now? Do you like it? Is there anything that you really like about what you're learning this year?
I personally really like multiplication and division and just math in general.
Oh, good. Well, that's good because you're on a math show, so it's nice that you like math and enjoy math and learning those new concepts and things. Tell us a little bit about theatrics kids because usually we don't have a lot of students that go there. So tell us, how did you get involved with that?
My mom is the director of it, and she had the idea of doing it. And we do theater, and just the program is mostly about theater and acting.
And how long have you been doing this?
I've probably been doing it for 2 years now. It's 1.5 years.
Okay. Do you do it for a long time? Like, do you do it every day, or is it once a week, twice a week, or is it just whenever it happens?
So the homeschool theatrics program is every day, and I come every day since I'm homeschooled with my mom, and we do theater and acting skills.
Oh, good. And is there a favorite thing about that you like?
I like acting because my favorite hobby is singing.
So you like singing. All right. You like acting. And word has it that you were in a movie also. Can you just tell us the title of that movie, what the name of the movie was?
It was called Hear Me, and it was a Logic film. It was from the Logic Films company, and it was fun. So
from Logic Films, Hear Me, and I believe that that's going to be open for release pretty soon in the spring, I think, where anybody can go check that out. So if you know of Logic Films or you want to look up Hear Me, it's a short film, correct? Mm-hmm. And you are one of the stars of the movie. Yeah. Nicely done. Well, you know what? Perhaps we'll get a little time for you to sing later on, but first you need to do some math. Are you ready? Uh-huh. All right, over to the board, young lady. So there are many different ways to multiply, and you can show us whatever way you would like to multiply. So Scott, if you want to put these numbers up on the board, okay. Let's go 63 times, and Scott, I'll let you choose the next number. It's got to be 2 digits, though.
Sure, how about 24? Can you do that one? Uh-huh. And tell me what you're going to do.
So what I usually do is I do 4 times 3.
Okay, what's 4 times 3?
4 times 3 is 12.
Good. All right, can you put the 12 down there in the bottom?
Yeah, so you do this one, and then you put the 1 up
There's no room for the 1. You carry the 1. Good, okay, what's next?
So I do 6 times 4.
Okay, what's that?
24. And then 24 plus 1 is 25.
Okay, where does that go?
The 25 goes right here.
Okay.
25.
Good. Uh-oh.
Whoa.
That's all right. That's why we have these erasers. Hooray for erasers. Good. What's next?
Then you put a 0 here.
I like that 0 there, yeah, because we have a little space holder, right? Okay.
And then you do 2 times 3, which is 6.
Okay.
And then you put the 6 right here.
Do you have to carry anything on the 6?
Nope.
Okay.
And then 6 times 2 is 12, but you put the full number here because...
Good. I like how you line those 2's up too. So that means you're all done with this problem? There's more. What's the last part?
Then you put a plus sign like that.
Yep.
And then you add it all up.
Okay. 5 plus 6 is what? 11. Oh, you carried the 1 there. I see what you did. 5, because 2 plus 2 plus 1, right? Okay, tell me what this whole number is.
1,512.
That's it. Well done. I like how you did that.
Nicely done. Now, Scott, you're comfortable with using an area model, correct?
Right.
Addie, have you ever seen multiplication with an area model? All right, so this, I'm going to have Scott help you out with this, because this is another way to look at it. And that way, sometimes you can visualize it, and maybe as you get into bigger numbers, it might be a step to do them a little easier. All right, so let's just put 1,512 off to the side. And we'll go ahead and, all right. So Addie, now you're going to learn a new way to multiply, okay?
Okay.
All right.
All right, our numbers were, let's see, we had 24, right?
Okay. And 63.
Oh, good
Right.
deal. Okay, so this is 63 up here and 24 over here. All right, we're going to break those up a little bit, okay, into the 10s and the 1s place. Okay, so 63 up here, would you agree that that's 60 plus 3? Is that okay? Yeah, and 24 is 20 plus 4. Is that okay? All right, so we're dividing this up into some different areas here. Now, we talked a little bit about area before the show, so you know how to do the area, right? So let's find the area of this square right here, or this rectangle.
So
20 times 60, right?
20 times 60 is 120.
Oh, I like what you did there. 1, 2, because 6 times 2 is 12, right? But how many zeros?
1.
1 there and 1 here, right? So a little bit more than 120, it's 1,200. Watch those zeros, huh?
Okay.
Okay, how about this one? 4 times 60. We're going to look at this rectangle right here.
4 times 60. Well, 4 times 6 is 24.
Good for you. Good.
So, and then a 0.
And a 0. Good. How about up here? What are we going to multiply to get this one? 3 times what?
20.
Good for you. That's it. So what's 3 times 20?
3 times 20 is 60 because 3 times 2 is 6, but you add the 0.
Add the 0. Okay, what's the last square we have to find out?
We have to find out 4 times 3.
And where does it go?
It goes in that square.
Can you put it in that square? What's 4 times 3?
So, well,
Okay, so if we found the total of all of these areas, if we added them all up together, what should they add up to? Do you see another number on the board somewhere? Let's do it. Are you ready? I'm going to write the numbers, and then you're going to add them up, okay? 1,200, and then 60. What else is left?
12
240.
and 240.
Once you write your 12 underneath there, because I know you like the 12 in red.
So
Good.
well,
Okay, they're all lined up. Draw a line and add them up. Let's see what you get. 6 plus 4 plus 1, 11. Good. Carry the 1. 5. What the heck? It's the same thing. And this is a wonderful picture of what's going on here. We added up the areas, right? Basically, we multiplied this times this side, which would be the area inside. We wish it in little pieces. And the little pieces aren't nearly as hard as sometimes a big, long multiplication problem, right?
that was cool.
That was pretty cool, huh? Yeah. Good
Oh,
job.
good. I'm glad you like that. Wonderful work for you there, Addie. Hey, we do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. And time now for today's Math in the News. All right, before we get to today's Math in the News, I have a simple question for you. Do you like sports?
I like gymnastics.
You like gymnastics? That's a sport. Okay. Is that your favorite sport?
Yes.
Okay. Do you like any other sports?
Acting and theater is technically a sport, so yeah.
Okay. But you like gymnastics. And that probably helps out quite a bit with theater. Have you had any favor Do you like at all baseball?
Yeah,
It's okay if you don't. That's
Yeah.
fine. You can say no if you don't want to.
I do.
You do. Do you have a favorite team for baseball?
I like the Dodgers.
You like the Dodgers. Well, you're growing up in Southern California. You should like the Dodgers, right? All right. Well, in the newspaper today, this one, it says, Derek Jeter, Larry Walker elected to Hall of Fame. And we have a photograph that was in the newspaper. That is of the captain. That is Derek Jeter of the New York Yankees. Have you ever heard of him or heard of the Yankees?
I've heard of the Yankees.
Oh, good. Well, here's how the article. I don't know what we're buzzing for. All it is a
rough
news
go, yeah.
article there.
Tough
Whoa,
crowd
guys
here.
elected to the Hall of Fame. You buzzing them. I don't know about that, guys in the back. Ooh. All right. Anyway, known for 2 decades as number 2, Derek is now linked to the number 1. All right. There are people that write for baseball articles, and they know a lot about baseball, and there's hundreds of them. And they get a ballot every year, and they see a bunch of players' names, and they vote. Should they be in the Hall of Fame or not? And there was only one person that voted not to put Derek Jeter in the Hall of Fame on this year's ballot. So that's why this is news right here. So, nice to see they're back in the swing of things in the back right there with the ding-ding on that one. Anyway, last year, Mariano Rivera was the only person in Major League Baseball history to get in with a unanimous vote, 100%. Every single writer
Every
said
person.
he gets in.
Wow. Okay.
This year, Derek was the first one to have one person leave him off.
Okay.
Before that, Ken Griffey had 3 people keep him off, which was unheard of even at that time.
Sure.
But, so that means Derek did not receive 100% of the vote. He received 99.7% of the vote.
Okay.
So we're going to take a look at percents right now, and we're going to see if we can figure out how many people there were. Because it said, let's see where it was. 219 ballots were made public.
Okay.
Okay? So we're going to put 219 divided by 220.
Good.
And then hit equal, and then times 100. So we'll have a decimal, we'll multiply that, and what percent do we get now?
We get 99.54.
99.54. That's not quite 99.7 though. We need to get a little bit higher. So that means there were 219 ballots that were made public, so there had to be more than that in order to get us to 99.7.
The secret ballots.
Right.
Uh-huh.
So let's try this. Try 396 divided by 397.
Ooh. So there must have, if in that case, there would be a lot of them secret.
Okay, then times that by 100. And what do you get now?
99.74.
There you go, 99.74. Now do me a favor. Scott, go on over to the board and write 99.74. Now, Addie, have you done any rounding in mathematics yet?
Yeah.
Do you have any idea what I'm going to ask you to do with that? Like, why would that be 99.7 instead of 99.8? You know why?
So you look at the 7, right? And the 4 is going to help you round. Does the 4 round the 7 up to an 8, or does it stay a 7?
What does it have to be to round up?
To round up to 8, it would have to be 1. It would
It would have to be a bigger number, right?
Yeah, it
Yeah,
would have-
like a 5 or a 6 or a 7 or an 8 or a 9, all those big ones. But the smaller ones keep it the same. So if it's a 0, 1, 2, 3, or 4, then it'll stay the same.
And that's how we get the 99.7%, because there were some that were made public, but some that weren't. And that is today's Math in the News and how we come about 99.7% on the Hall of Fame ballot. Say we do have phone tutors available until 5:30, but right now we have an opportunity to head and about with Marylou.
Today we are at COM, and I'm with Steve Sanders, Chief of Staff with Kern County Superintendent of Schools.
Correct. Yeah.
And we are out here at a different kind of spot with COM.
Yeah. So this is our Desert Bighorn Sheep exhibit. This is an example of one of the things that we do with Holiday Lights revenue. So we just celebrated a successful Holiday Lights, and those funds help this zoo grow. And so in 2010, we built the Desert Bighorn Sheep exhibit, and this is unique because this is a breeding program with San Diego, Los Angeles, and about 10 other zoos, all to breed the very endangered Desert Bighorn sheep. So right now we have a group of, these are all female bighorn sheep. We've had a lot of success with breeding babies in this program since it started, and just about 2 months ago they moved our male out to another zoo so that he could breed. It's all based on genetics and all about strengthening the herd. But when we started this program, there were about 70 bighorn sheep on exhibit in the whole country, and we had about 4 or 5 of them. And so this herd will grow anywhere to about 10 bighorns, and then they'll move them off to the other zoos based on genetics, all around, again, strengthening this endangered species.
Well, these particular ones that are behind us, how long have they been here at the zoo?
Let's see. Our curator of animals could tell you better, but I would say we've had, the very first year we started this program, we had 2 or 3 babies. So some of them have been here, the last 8 or 9 years. And so it's just a great program to be able to teach kids about this endangered species. And that's really what CALM is all about. All of the animals we have here are native to California, just like the Desert Bighorn sheep. And these are something that kids here in Bakersfield probably wouldn't see in the wild, and they get to come out here and experience them.
I didn't even know you had this until we
Yeah.
walked out here. So the area is just right here, correct?
It is, and it's a perfect place for the bighorn sheep. This is a piece of property that we probably couldn't develop as another exhibit. It's not very conducive to people walking around, but it's perfect for desert bighorn sheep who love to climb. It has the gullies, and what I love about it is when you're on the train and you're coming around this way, you can see the desert bighorn sheep. So.
Now, you said everything is native to California, correct? And everything has its different climate, correct?
Yeah, so I mean, these guys hang out in the desert, and then, we have other animals here that are all from different parts of California, but they all do well here. And one thing, that was part of the mission of CALM from the very beginning, is making sure kids in Kern County know about the native flora and fauna that is indigenous to this area.
Is there anything in the future that you guys are going to be bringing in new?
Well, we're always thinking about the future, and so that's kind of the challenge we have with CALM. Is this is a facility that's going on 37 years old, and so we have some things we need to fix and upgrade, but we also want to always think about adding new exhibits. So we've talked about things like river otter, which would be an amazing species to have on exhibit. But I think over the next couple years, we're going to focus on really upgrading those exhibits that we have and giving those some love as well.
Didn't you open one new exhibit? Was it last year?
We did. So it was in 2014, I think. We opened the California Condors, which we'll talk about. But those are highly endangered birds, and we're lucky to have those. And then we did open the California Coast Room just the past couple years. And that's an indoor exhibit all about bringing those native sea creatures to Kern County. Because we know from operating Camp Keep at the superintendent of schools, over 30% of the kids that go out there in 6th grade have never been to the ocean, even though they only live a couple hours away. So we want to give that experience for kids here.
Awesome.
Yeah.
So when we come back, there's so much more to see. I believe we're going to go see the condors possibly.
Yep.
Okay, so we're going to send it back to the studio for now.
All right, thanks for that, Marylou, and also thank you to Steve from the Kern County Superintendent of Schools office, as well as CALM. We do have phone tutors available until 5:30. We have Addie, a 4th grade student, in studio with us right now, doing some great multiplying, as well as helping me out on the calculator, figuring out percents. But right now we're going to go to the phones. And Logan, how are you this afternoon? Hello, Logan.
Hey.
You're a 7th grader, correct, at Freedom Middle School?
Yes.
All right, so go ahead and read the math problem for us, and we'll go ahead and get started on it.
Okay. So there are 2 solids, and they are both triangular prisms. The smaller one has the height of 5. The length is 12. The width of 6 in the foot height of 13.
Gotcha. So there's two of these shapes, right? And does the
Right.
problem say that the shapes are similar, Logan?
Yes.
Okay, gotcha. So what's the goal of this problem? What do we need to know about the next part?
So we need to find the missing dimension.
Okay. Do you have any of the dimensions that are given?
Yes.
Okay. What do you
One
have?
dimension that is given is the height of 7.5.
Gotcha. Okay. So that's an important piece of information. So the first column, I've written all the numbers you gave me there. And the second column, we'll see what we can figure out to do or to find the other dimensions. Now, the problem doesn't ask about surface area or volume or anything like that. We're just looking to find the dimensions of this thing. Have you done problems like this before, Logan?
No.
Okay. Well, this is about time to do it, I guess. We need to change. So here's one way to look at it. The small shape that you have has a height of 5, and the new one has a height of 7.5. How does 5 become 7.5?
Well, you would have to add 2.5.
I like what you did there. Yeah, you could add 2.5. So that's one way to do it, okay? So one way to do it is to add 2.5. Is there a way you could do it with multiplication? Because we'd like to have the same ratio for all of these measurements, all of these dimensions, in the form of a multiplication problem. So it's kind of an interesting way to think about it, but 5 times some number equals 7.5. Can you think about that in your head? What would that number be if we had to multiply it? 5 times 1 is what?
5.
Good. What's 5 times 2?
10.
Gotcha. So 1 is too small and 2 is too big, right?
Mm-hmm.
So what's the number that's right in between 1 and 2?
1.5.
I like it. All right. So can you do this problem for me real quick? What is 5 times 1.5? If you have a calculator there with you, you can do it, or you can work it out on some paper.
1.5. It is 7.5.
It is. That worked out pretty well, right? So what we have done here is we have actually we found something called the scale factor, okay? And what that means is kind of like on a copy machine where you can make things bigger or smaller. It's the same type of shape, but you can make it everything bigger or everything smaller. We're going to make everything a little bit bigger, and we're going to multiply all these numbers times 1.5, okay? So let's look at the length here. The length of the small figure that you have is 12, and we're going to multiply that times 1.5. Can you work that out for me and see what you get?
I get 18.
Aha, 18. So the new length of our shape is 18. What about the next one? What would you do in the next one, Logan?
So I would just multiply 6 by 1.5.
Good for you. And what do you get?
I get 9.
Okay. Looking good so far. What's the last one?
Then 13 times 1.5 is 19.5.
19.5. All right. The only other question I have for you is it looks like we have all the dimensions you need to have a similar triangular prism. My last question for you, anywhere in this problem, does it tell you what kind of units you have? Do you have centimeters or miles or inches or something?
I have meters.
Meters. So that's kind of an important deal. Even though you're not finding the surface area, you're not finding the volume, so we don't have a final answer that has, you know, meter to the second power or meter to the third power. We want to put all these numbers, make sure they have a measurement on them so we know exactly what we're talking about here. So you said meters, is that right?
Yes.
How do you abbreviate meters?
M.
M, gotcha. So next to all these numbers, 5 and 12 and 6 and 13, you can put an M, and next to all of our new numbers as well. 7.5, 18, 9, and 19.5. And now we really know what we're talking about. So if you had to build this thing in real life, you'd know exactly how big it is. And boy, a triangular prism that's, 7.5 meters high and got a slant height of 19.5, that's a pretty big structure there. So we can at least get an idea of what's going on there. But that's what we found here, okay? If you need to write that down for a little vocabulary, the scale factor is what you found, okay?
Nicely done, Logan. Great problem right there. And congratulations. You've just got yourself a couple of tickets to any athletic event, courtesy of our friends at CSUB Athletics. So I know that basketball is going on, wrestling is going on, I'm sure swimming is going to be coming up, baseball, all sorts of things going on there. So congratulations on that. In studio, we have 4th grade student Addie. Are you well rested?
Yeah.
All right, because Scott and Logan were just doing a lot of work, so it's time for you to get back to work. So let's head over to the board. We'll clear that up, and we'll go ahead and work on one of the problems that you were working on. So this is something that you are working on right now as far as mathematics is concerned. So we have 5 over 6 is equal to something over 24. So Addie, if you could, tell us what are we doing? What are we looking for? What are those fractions called, and how are you going to do it?
So these fractions, we're trying to get what this number is gonna be, and we're trying to find out what this number is.
Right. And what's the sign in the middle?
It's an equal sign.
Equal. So this fraction is actually equal to this one. You ready for a little vocabulary? Last one was scale factor. This vocabulary for math is called equivalent fractions because it has equal in it. Can you say equivalent?
Equivalent.
Equivalent, gotcha. So we want to find equivalent fractions. How do you do this problem?
Well, what I was taught is that you find out 6 times what equals 24.
6 times some number, kind of like the scale factor like we just did. So 6 times what number is 24? Times 4. Okay, so you figured out what that is. So why is that useful?
Because if you do 6 times 4 equals 24, then you put the times 4 up here, and you have to do 5 times 4, and that number is the answer.
Do it. And what do you get? 5 times 4?
5 times 4 is 20, and that would be your answer for that.
20 over 24 is the same as 5 over 6, they're just bigger numbers, equivalent fractions. Good job.
Nicely done. So leave that up on the board, and what I'd like you to do is underneath it, let's put this one.
Okay.
3/7
Uh-oh.
times 12 over something. So instead of looking for the numerator, you're looking for the denominator now.
Oh, can we put equal sign here? So we're going to make
Yes.
these equal, right?
I'm sorry, did I say times?
Yeah, that's
okay,
right.
yeah, so we're doing equal. Sorry about that.
Okay, so Addie, we're looking for what goes in the circle, right? So what are you going to do now?
The same thing that you do usually.
Are they still equivalent fractions?
Yes.
They are, aren't they? Yeah, that's right, because they have an equal sign. We want to make sure. Good. Good. Oh, I see what you did there. Okay. So 3 times 4 is 12. So that's, you found like the scale factor, right? What about 7 times 4? 28. That's it. And you have equivalent fractions because you have an equal sign. So it looks like it doesn't matter whether you're missing the top number or the bottom number. You can find out that number by finding the number that you multiply by, right?
All right, here you go, hot shot. I got another one for you over on the left. Here we
Okay.
go. 10 over 12 is equal to blank over 6.
Ooh.
Okay. So.
Are these equivalent fractions?
Yes.
They are. yeah.
Yes.
Yeah, as long as they have an equal sign. Equivalent fractions, we're going to make sure. Ooh, she's thinking. Tell me what you're thinking out loud. I want to hear it.
I'm thinking that because this is smaller, and this is bigger, we could see what we have to do to get 6 times what to equal 12.
Oh, going the other direction. Okay, gotcha. So what would you do there? 6 times what?
2
I like that. So 6 times 2 is 12. Good. What are you going to put on the top?
times 2.
Now
So
hold
you
on. We're
kinda-
not going this way, right? Look where your times is. Okay? So I want you to put the times on that side.
And then
Good.
that equals 5.
What? How'd you get 5? Where did that come from?
Because if you have 2 5s, because 5 times 2 equals 10.
Gotcha.
So if you have 2 and you have to find out what you have to get to 10, that's fine.
Good. I want you to think real hard now. If you didn't have the times here, what could you put here before the 2 so that we could read the problem this way? 12 something 2 equals 6. Ah, so you can divide 2. Let's see if it works on the top. Does it work? 10 divided by 2 equals 5. 12 divided by 2 equals 6. So you can multiply or divide as long as you do the same on top and bottom, right? Divide by 2, or times 4 times 4, right? Good job.
There you go, nicely
Equivalent
done. I
fractions.
just wanted to see if she could see that other way going back.
Yeah, that was
But you were
great.
able to do it both ways there. So congratulations, you've got yourself a couple of tickets to go see the Bakersfield Condors. So congratulations on that. We I actually had an opportunity to go see the Condors the other night. They had a fundraiser going, so we went out, and a lot of fun. If you haven't had an opportunity to do so this year, they're right in the middle of the season. We'll be back with more right after this. Today we're at Highland Elementary, home of the Hawks, and we're here to... All right, once again, we're at Highland Elementary, home of the Hawks. We've got some 4th and 5th grade students. We were talking a little bit about angles, right, and triangles, okay? So you're gonna need to remember that knowledge that you have in order to do these problems. So, the 3 of you will have these clues to work with, all right? You 2 guys ready? All right. So those are your clues. And each of these puzzles is different. So if you see somebody starting to make some shapes with theirs and you look, oh, maybe that's like ours, they're completely different puzzles, okay? And I don't even know which ones I gave each of you, so it's just random draw right now, all right? So what I want you to do is, first of all, take off the paper clip and take a look at the different clues that you have for your puzzle. And you can just kind of lay them out in front of you so that you can see all of them at the same time. So you should have 6 for each of yours, okay? So let's take a look at one of your clues. Pick any one of your clues and go ahead and read it.
The figure has 2 triangles and 1 square. All the sides are either 1 or 2 sticks long, no broken sticks. Make the figure.
Okay, so you know that there's going to be 2 triangles and 1 square when you eventually make this whole thing. But all the other clues will kind of help you figure out where everything goes, all right? Go ahead and read one of your cards.
The figure is made up of 2 triangles that are not congruent.
So do you guys know what congruent means?
No.
Same shape and size. So if they're congruent, they have to be the same shape and the same size. So are yours congruent or not congruent?
Not congruent.
So that's something you're going to need to remember, all right? What about one of your clue cards?
The triangle and the square share a side.
So the triangle and the square share a side. So that, right, if we had a triangle and a square, could I go like this?
Yeah.
Because then the square and the triangle share a side, right? You said that you had 2 triangles that are not congruent, right? So I could have one like this, and then I could have one like this, because they're not the same shape or size, are they?
No.
No. And what was the one you had? You have 2 triangles and 1 square. So yours could look something like that even, where you have 2 triangles and 1 square. So we don't know how it's going to look yet, right? So with your partner or partners, go ahead, take a look at all the clues. You have the sticks inside the bag. Go ahead and see if you can make that stick figure, all right? Go ahead.
So, 6 of the sticks in the figure are so 12. Neither. 6 of the sticks in the figure 9, 10.
You guys have a little something going. You have all 12 there?
Yes. One triangle has a perimeter of 7 sticks. Oh.
So let's count the sticks, all right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So how many sticks are in your figure?
11.
11?
12.
Well, we counted that,
Oh.
right? So here we have 3, right? And there's 4, and there's 4. So we have 11 sticks. So how many does your need?
12.
So here's that other one. So you need to figure out where that one goes.
Isn't there a square? Maybe what we could do
There's only one triangle.
make like
It's not as easy as it looks, is it? All right, keep working. There you go. You've got a pentagon. Very good. Do you need a pentagon in yours?
no segment figures shorter than 2 sticks.
When it talks about the perimeter, what does that mean? You guys know what perimeter?
Outside.
Right, the outside.
The area is the inside.
Area is the inside. Perfect. There we go. And the 4th and 5th grade students working on angles, triangles, congruency, perimeter, all of those great things at Highland Elementary. And once again, a big thanks to the staff and students at Highland Elementary. Always have a great time when we're able to visit some schools. Right now, we're able to visit COM once again. Check out what Steve and Marylou are up to.
We are back at COM with Steve Sanders, and we are in another area.
Yeah.
Can you kind of tell us a little about what area we're in?
This is a special area. It's obviously the California Condor area. So this exhibit was opened in 2014 after about 10 or 15 years of trying to get California condors here at COM. They're an important bird because they're native to Kern County. In fact, this is kind of the flight path that we have for California condors, right over Bakersfield up to Tehachapi. And so what's great about these birds is these are 2 males. They came to us from the Oregon Zoo, and they cannot be released to the wild, but when we got them, they were about 12 years old, and they'll live to hopefully 50 or 60.
They actually live that long?
Yes, and so they'll be a part of COM for a long time. And what's great about the California condors is they are so endangered that they got down to about 22 birds left in the world. And they were, the birds were captured, bred, and now there's about 500 California condors, in existence. And so these are not breeding birds, but they're obviously important from an education standpoint to be able to showcase these birds to our kids.
Now, did you have to go through a lot in order to get them here? Because you said it took
did.
a long time to
Yeah,
get.
it's very political, I guess you could say, in terms of where birds are placed. There's a program called the California Condor Recovery Program that we expressed interest, to them, that we wanted these birds. We had to do some renovations to this exhibit, and we waited about 10 years before these birds became available. Oregon needed to make room for breeding birds that they were able to secure. And so we were able to give these 2 guys a great home here. But what's amazing about them is they have a 9-foot wingspan.
Now, is it?
Yes.
Actually,
this
is this
says 9.5 feet, but yeah, so right around there. And during the summer months, I love it because you can see number 24 there, sits on the log and suns himself. I've been out before where the other condor was taking a bath, right here where people can see. And they're just amazing birds. One thing that people say is, wow, they're kind of ugly, but I actually think they're beautiful. They're part of the vulture family, and but they have their own beauty and majesty.
Now, is there special eating habits that they have?
Well, we actually do feed them deceased calves and other animals, so they're scavengers, and so that's one of the things that we do here in this exhibit, and it's part of their enrichment is to be able to eat like they would naturally, so we make sure that happens here.
Okay, so you said number 24.
Number 24, he has a big tag on his wing, and he was actually acclimated to humans. I guess a group of hunters had been feeding him, and so he got used to humans, and once that happens, they call that imprinted. They're not able to hang out in the wild anymore, and so they were captured by the Condor Recovery Program and given a life here because they would not survive on their own that way.
So they obviously have numbers, they don't have names then.
Correct. These 2 don't have names. We've just kept their numbers, but they're amazing birds. And, the kids, especially number 24, he likes humans. So when there's kids out here, and especially during the warm months, he's right there sunning themselves, and, kids are able to see these great birds.
Anything in the future of getting more?
Yeah, we'd actually, right behind us, we'd love to develop this area as a bigger condor exhibit because these are birds that people, kind of have an affinity for and are curious about anyway. So I'd love to expand this area as well.
Now, just not the condors are here. You have, looking around, there's multiple areas with other birds.
So this is called our raptor round, and so we have two bald eagles right next door. We have golden eagles. We have an osprey. We have our ravens and crows over here. And so, yeah, this is definitely for those bird lovers a great part of CALM where they're able to see those majestic animals.
Awesome. Okay, so there's a lot more to come here from CALM, but we'll send it back to you at the studio for now.
All right, thanks for that, Mary Lou, and thank you also to the staff at CALM, most accommodating every time that we go out there. And I know a lot of folks won a lot of tickets here from Do the Math to go out to see the holiday lights at CALM. That ended a few weeks ago, and we went out again this year. There's always something a little bit new out at CALM as far as holiday lights, and always something a little new as far as CALM itself goes. So if you've not had an opportunity to go out to the zoo recently, by all means make a plan for, maybe you want to wait until it gets springtime and a little bit warmer out, but always a lot of things going on out at CALM. All right, Addie, you ready to work again?
Yeah.
All right, back to the board. So before you were talking about equivalent fractions, and you kind of got the hang of that pretty good. So now what we're going to do is we're going to add some fractions. So let's go 2/5 plus the same thing. And Addie, how would you like to start that problem? What do you know? Do you know any vocabulary, kind of what you're going to do, or what are your thoughts?
I think that you add the 2 plus the 2.
Okay, show us.
So 2 plus 2 equals 4.
Okay. What about the 5s? What do you do there? That's an interesting question, isn't it? Here's a good question for you. Here's the way I love to teach it, and this is a way that everyone can understand it. Ready? What is 2 cents plus 3 cents? What do you get? 5 what? 5 cents, right? So what if this didn't say cents? What if it said apples? 2 apples plus 3 apples. What do you get? 5 apples. Now here's why I'm telling you that, okay? We're gonna put this problem into words. Tell me what this fraction is, please.
2/5.
2, here's how you spell it, it's really weird. F-I-T-H-S, fifths, plus, what's this fraction?
2/5.
2 fifths. Now we as mathematicians don't always use words, but I think this is one of the situations where it really, really, really helps. What do you have? 4 what? It makes sense, huh? 2 cents plus 3 cents is 5 cents. 2 apples plus 3 apples is 5 apples. 2/5 plus 2/5 is 4/5. It totally makes sense, right? So tell me how we write 4/5 in a fraction. Oh, now you know, right? Why does the number stay the same? Why does it stay the same?
I remember now.
Yeah, it's the same word, right? It's the same exact word. If we were going to make a picture of this, right, we would have maybe a circle, a pizza, or a pie, or something fun like that, right? And we have...
Isn't pizza really pie?
Yeah, pizza pie. Yeah, that's even better, right? So how many? 1, 2, 3, 4, 5. Not a very good drawing, but I'm a mathematician, not an artist, right? So the first one says 2/5. 1, 2. And the next one says 2/5. 1, 2.
There's one left.
And then we have one left, but how many fifths, how many pieces of pie are shaded in?
4.
4 out of how many total in the whole pie?
Out of 5.
5. So this is a picture of it, this is a word representation of it, and here's the math part to it. So in addition, add the top, don't add the bottom. Whoa, look at that.
All right, so let's get rid of that board. Now let's try it on our own here, all right?
Here we go.
Here we go. So let's go 3/9 plus 4/9.
Ooh, okay. Addie, see what you can do. Where'd you get 7?
From 3 plus 4.
Good, I like to hear it out loud. Good for you.
And then the bottom stay the same.
You sure it's not 18?
Yep.
Why?
Because in math, you only add the top in fractions and not the
In
bottom.
adding the fractions. That's right. Good job.
There you
All
go.
right, I like that one.
Nicely done. Well, you know what? We have one more opportunity. This time, actually, we're going to go check out what an elementary school with a STEM night at Stockdale Elementary.
It's a night to come out with your parents and have time to play math and science games and watch some engineering demonstrations, build some things. It's really important to promote science, engineering, STEM. We've got Era Energy and Kern Tutoring, Quantum Kids Labs, and then we have a lot of stations that are just run by our school. We have the BHS Society of Women Engineers here tonight.
Females are typically the minority in STEM fields, and the purpose of Society of Women Engineers is to show that we don't have to be the minority, that we can do it just like anybody else. And so I think it's really empowering for all the young ladies to see that, hey, you know what? It's not just a bunch of guys standing around the table, it's people like us, it's girls like us. STEM is fun, everybody can do STEM, and it's actually interesting. So we're teaching people about the scientific method, and by having them do these experiments.
7, 8, 9. We have a lot of wonderful families, so I'm really glad we can provide something for them to come to and experience school at night and fun and interactive.
There we go, doing the science, doing the math, doing all sorts of stuff at the STEM night at Stockdale Elementary. And by all means, if you have a night coming up like that at one of your schools, Do the Math would be more than happy to come on out and share some games and things like that with you guys as well. We do have phone tutors available until 5:30 this afternoon, but we have Addie in studio, a 4th grade student who's been working on equivalent fractions and now adding fractions with like denominators. So now it is time for the next step. Are you ready? All right, I'm glad you have a good attitude about this. Over to the board, young lady. So explain to us once again what you were doing with that problem and how you ended up with 7/9, 7/9.
So I added 3 plus 4, which equals 9, and all bottoms stay the same.
Gotcha. 3 plus 4 is 7, and the bottoms stay the same.
All right,
So what if the bottoms aren't the same?
Yeah, so you're comfortable when the denominators, the numbers on the bottom are the same, right? Okay, so here we go. Scott, let's go 2/6 plus 1/3. So now the bottoms are not the same.
Oh, goodness. Wow. Wouldn't it be nice if that was a 6?
Yeah.
Yeah. So remember what we did at the very beginning of the show? And we changed the fractions, right?
Yep.
Can we do that? Way over here, ready? We have this 1/3, and we would love if this fraction had a 6 on the bottom instead of a 3. Don't look at that. Try this one over here. Just like at the beginning of the show, what do you do in that problem?
You do this,
Good.
that,
Okay.
and then what you do before that is you do this times 2, which equals 2.
Gotcha. So, tell me what the word is again.
Equivalent.
Equivalent fractions. They're equal to each other, right? So instead of writing this 1/3, we could replace it with, what is 1/3 equal to? Write it down. What is it equal to? What's this new fraction that you made? That's it. So now, well, actually we can put a little equal in there, right? 1/3 is the same as 2/6. So now we're adding 2/6 plus 2/6. Are we allowed to add those now? Get her done.
Okay, so these two, that equals 4.
Okay, on the top.
So 4 on the top.
Good.
And then the bottoms stay the same.
Bottom stays the same, that's right. So if you have a fraction when the two denominators, the numbers on the bottom, are not the same, we have to make them the same before you add them together. Okay? Think maybe we should try another one?
Yeah.
Here we go.
Okay.
3/5 plus 2/10.
Okay. Are they the same?
No.
Darn it. Okay. Do you want to make them both into 5 on the bottom, or do you want to make them both into 10 on the bottom? What do you think?
Both into 10.
Let's make them both into 10. So we're going to leave that one alone. So write the problem on over there on the side. What are you going to do? Make 3/5. Good for you. Yeah. Equal to something with 10 on the bottom. Yeah. Remember, they are, what's the word?
Oh, equivalent.
Equivalent. Good. Okay, so how do you make 5 into 10? Good. Times 2. Tell us what you're doing here. What's 3 times 2?
3 times 2 is 6.
Good. So what is the new fraction that you've created?
I have made 6/10.
Okay, so which fraction is that going to take the place of here?
It's going to take the place of this one.
Well, we already had 2/10 there. Right? We already had 2/10. We don't want to erase that part, right? We were going to leave this one all alone. You said 3/5 is going to be 6/10, right?
6.
So instead of writing 3/5, can you write 6/10 right there? What is the new problem that we have? It's not 3/5 plus 2/10 anymore. What's the new problem?
It's 6/10 times 2/10.
Not times.
Plus.
Plus.
2/10.
Can you do that problem? Okay, let's see it. And this is the kind of problem where the number on the bottom stays the same, right? So you change the bottom number, but when you change the bottom number, you also have to change the top. And you did that, and now you can add them together.
All right, I've got one more for you.
All right.
All right. Here we go. 2/4 plus 3/8.
Ooh. That looks like fun. You want to change them both into fourths or both into eighths?
Eighths.
Good idea.
Okay,
So leave that one alone. Tell us what you're doing.
What I'm going to do is I'm going to do what we did at the beginning of the show.
Okay.
We're going to do that one times that one, but we don't know that one.
Yeah, we don't know yet. 2/4, what are you going to change it into?
I'm going to change it into...
Not plus. Equivalent fractions, right? Change it into a new fraction with 8 on the bottom. Tell us what's going on.
So 4 times what equals 8, and that's times 2.
Good.
So 2 times 2 is 4.
Good for you.
And then
So now you're going to use that new one, right?
this one will replace this one.
Good for you. That's it.
And after you do that, then you do this problem.
Can you do that problem? Are you allowed to?
Uh-huh.
Why?
Because all the bottoms stay the same, you just have to add the top.
Yeah, that's right.
All right, there you go. Nicely done, 7/8 for some great work on that. You've got yourself a meal courtesy of our friends at Broken Yoke Cafe. So congratulations on that. They've got some delicious food items over there. Hey, we do have one more opportunity to head on out to COM and check out what Marylou is doing.
We are back at COM, and I'm with Steve Sanders from Kern County Superintendent of Schools. We saw the bighorn sheep, the condors, and now where are we at?
We are at the California Coast Room. This is COM's newest exhibit, another example of what is made possible through holiday lights. So the vision behind this room was to have a place where kids could learn about native sea creatures that are native to California, because we operate Camp Keep, and I know you've been there, and we know that about 30% of the kids that go to Camp Keep have never seen the ocean, and so we wanted to bring some of that to Kern County. So what we have here is our moon jelly exhibit. These are native moon jellies, and obviously peaceful, and something that kids don't see on an everyday basis. And then we also have in this exhibit our seahorse exhibit, an octopus. We're waiting for a new octopus, so that tank's empty right now. But we have our seahorses, which are amazing animals, and again, something that kids don't always see. And then behind that, we have our touch tank. And this is an important, feel free to go ahead and touch around. This guy is super cool. But these are almost like a tide pool. And so we wanted to be able to give kids that come to CALM on a field trip the opportunity to feel these creatures with their own hands.
I know at Camp Keep, there is a time they go down to the
Correct.
pier and they get to touch everything. Is that the same thinking with
Same thinking here. It's a chance to, we get a lot of kids through CALM, especially in first, second, third grade. So we want to give them that experience so when they do go to Camp Keep, it's, not entirely new. But we have a docent that staffs this every day that it's open. And we have about 25,000 kids that come through CALM on field trips. And so, it's a great way to get out of the textbook and actually feel things with their hands. And so it's a very popular part of CALM.
Yeah, definitely. This is, I know with the kids, this is a big thing, especially with learning when it's a hands-on, how important it is.
Yeah.
Now, you have the hands-on tank, and again, I know that you're getting the new octopus, which it was really cool to see. And the seahorses over there are absolutely beautiful.
Yes.
Is there any others that you were going to be adding on
Yeah,
this
we'd love
area?
to add more California sea creatures. So, like everything here at CALM, it takes money. And so we're always trying to think ahead and say, what else could we do with the support of our donors and Holiday Lights? And so this is an area right here that's unused right now. We want to make that a hands-on interactive area for kids as well. But again, it's all about teaching kids about the amazing native plants and animals that are right in their backyard.
Let's talk about sponsorship, because this room was hugely part of that.
Yes.
So if somebody wants to become a sponsor, besides Holiday Lights, how else can they sponsor?
Well, they can go to our website, calmzoo.org, and there's sponsorship opportunities on there. They can call Steve Sanders at the superintendent of schools, and we have opportunities for every level of sponsorship. But this zoo was made possible from the community, and it continues to grow all with the support of the community. So I always tell people, we can do anything at CALM as long as the community is behind us. And so, we're celebrating 37 years, which is relatively young for a zoo, but we hope to be here another 37 years plus and continue to grow.
So the sponsorship, again, contact you, correct? And there's so much, it's just growing.
It just is growing. And, again, CALM wouldn't be possible without sponsors, without our docents, without our volunteers, our amazing staff. We have a team of 8 animal keepers, our gift shop staff. We have 1 maintenance guy, 1 grounds guy, 1 custodian, and they do an amazing job presenting CALM to the public. And, we've been voted the Bakersfield's favorite family attraction. For a reason, because it's a special place.
And real quickly, aren't you up for something?
We are, thank you. So Holiday Lights was nominated this year as one of the top 20 light shows in the nation by the USA Today. So we're currently ranked number 9. Voting's going on, and I'm just excited about that notoriety.
Well, again, thank you so much for talking with us today, and then so many wonderful changes going on.
Yes.
So come on out here. It opens, CALM normally opens up at?
We are open 9 to 4 pretty much every day of the year, and so come out and visit us and ride the train, come and visit the Coast Room, and just enjoy what's right here in your own backyard.
Again, thank you for your time today. Another great time at CALM. We're going to send it back to you at the studio.
All right, thanks for that, Marylou. Thank you, Steve. Thank you also to Addie for coming in this afternoon, doing some great work. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.